Climate change is expected to worsen the frequency, intensity, and impacts of extreme weather events, increasing risk and extent of wildfires, widespread droughts, as well as species extinction. As Canadian author Margaret Atwood once said, "It's not climate change, it's everything change." And how does agricultural land respond to climate change?
Farmers have signaled intentions to plant more corn and less soybeans in 2019. How many acres actually get planted may well depend much more on Mother Nature than the festive.
U.S. corn and soybean harvest is moving forward. Farmers in the U.S. are typically beginning row crop harvesting.
This is the headline that was recently out. As climate crisis heats up, flooded farms in the Midwest can't plant corn. It's affecting crops.
Corn production in the U.S. is dominated by the Great Plains of central United States, the Corn Belt. The Corn Belt, roughly including 12 states, is one of the most fertile regions, producing more than 10 billion bushels of corn each year. Corn yield trends are positive across the Corn Belt. As darker yellow indicates of more production of corns, we could obviously observe that the centroid of the corn production is moving northwest over the last 50 years. In the highlighted area, mostly in the north part, the yield has increased by over 100%. The shifting of yield centroid is mainly because of the changing climate. As climate warms, plant honey zone, which tracks average low temperature in winter, are moving north in the U.S. at 13 miles per decade. As the most important crops in Corn Belt, corns and soybeans are planted in plant honey zone 5 and 6. However, since the plant honey zone is shifting north, while the more suitable conditions for commodity crops may shift northward to states like Minnesota and Dakotas. The climate model shows a similar prediction. It predicts a rising average temperature, which will affect crop growth. According to the Hurley 3 model, area-weighted average yields are predicted to decrease by 30 to 46% by the end of this century under the slowest warming scenario, and by 63 to 82% under the most rapid warming scenario. Both the shifting of plant honey zone and the climate prediction model indicate that climate change will probably push corn growth regions north. It is expected to be new corn agriculture in northern states, and the southern part of the Corn Belt is vulnerable due to higher temperature. To maintain the agricultural production in southern Corn Belt, farmers may change the crop type to adapt to climate change. Cotton, for example, is currently dominant in Cotton Belt in the plant honey zone 7 and 8. As the weather gets warmer, it is likely that the Corn Belt would grow cotton as an adaptive crop in the future. However, by comparing the corn distribution of 2010 and 2021, there's no obvious change indicating the Corn Belt moving north spatially, which is contradictory to the prediction and climate model. The land use of the Corn Belt remains stable. There's even an expansion of agricultural land due to higher corn price in recent years. A study of the migration pattern in the agricultural regions, which reported to be under climate pressure, also shows that there's no significant trend of farmers moving north. As the yellow and green color representing people moving north and south, it seems that climate change hasn't shown an effect on people's moving pattern. As models are predicting the Corn Belt is moving north, despite being aware of this prediction, why aren't farmers moving north as well? As we can see, vast acreage of corns and soybeans are watered by center pivot irrigation in western Corn Belt states, changing a near-desert region into the largest agricultural region in the U.S. Irrigation and evaporation creates microclimate to reduce the temperature and heat effect. The spatial distribution of changes in irrigated acreage reports a decrease in western United States, and as shown in blue, an increase of irrigation is concentrated Midwest, especially in Corn Belt. Where surface water supplies are insufficient, groundwater is often used for irrigation. Agriculture uses about 53% of groundwater pumped for human use in the U.S. Taking advantage of this incredible amount of water resources provided by Oglala Aquifer, there has been significant crop production for decades in the 12-state Corn Belt region. Its water supports $35 billion in crop production each year. While these regions are now under more and more severe water stress, as the Oglala Aquifer will be depleted and ultimately exhausted. Once depleted, the aquifer will take over 6,000 years to replenish naturally through rainfall. Concerning of the possible depletion of aquifers, a lot of organizations has been investigating on aquifers since 1970s, trying to find out a sustainable way of usage. USGS started to gather water level monitoring data from multiple organizations in the first place, cooperating with universities and regional organizations. The US government is able to track the dynamic water level. Constantly updated data could help local water management departments in decision making. The most common aquifer survey is by in-situ tests through pumping wells and monitoring wells. The test is conducted by pumping water from one well at a steady rate for at least 1 day, while carefully measuring the water levels in the monitoring wells. Calculating the triangular relationship of pumping, image, and monitoring wells, aquifer boundaries can be mapped through connecting the midpoints of pumping wells and image wells. By continuously establishing the wells and calculation, researchers were able to draw the boundary of the aquifers. The calculation of the boundary are based on a conceptual model called Theis equation. However, the equation relies on a large number of assumptions. Although none of the conditions could be fulfilled in real world, the Theis equation is still considered the fundamental model for aquifer testing. While monitoring water level is just a part of knowing aquifer, to predict depletion of aquifer, more organizations were involved in the investigation. The remote sensing data is mainly collected by NASA, which updates the water level data globally. With open access to the whole world, not only the researchers but also the agricultural companies can be benefited from it. Some organizations like NOAA and Agriculture Department also contribute through collecting and analyzing climate data. The model researchers from the government and academic organizations have developed multiple models for the aquifer survey. Even though we have these models, do we really know when the aquifer will deplete? To answer this question, we need to know the process of water circulation. Groundwater is recharged from precipitation and canal seepage. It's pumped out for irrigation and emerges back to the land surface to keep the water cycle going. This process is also used for the prediction of aquifer depletion. Two research groups led by Kansas State University and USGS investigated on this issue separately using different models. Through importing different datasets, they got two completely different output scenarios. While Kansas University predicted that Ogallala Aquifer would deplete in 2110, USGS believed that the depletion was in the far future. These different results show that, although we rely heavily on groundwater resources, it seems that there is no agreement on when the aquifer will be depleted. However, the U.S. agriculture keeps using groundwater, especially in Corn Belt. More than 90% of the water pumped is used to irrigate crops. Among them, Nebraska is the biggest consumer, taking 46% of the annual pumping water from the Ogallala Aquifer. The number of irrigation wells in Nebraska has exploded from 100,000 to 250,000 registered irrigation wells since the 21st century, and additional of 16,000 registered water wells. The fourth color satellite images, concentrated in the dense wells area, shows the spread of center pivot irrigation in Nebraska. The bright red colors shows healthy vegetations with irrigation in this fourth color composition. As we could see that irrigation is unsustainable and costly, it's more like an attempt to fight with the harness zone, changing the microclimate and trying to keep the zone 6 as it is through irrigation. Why do people still keep investing on irrigation? Government payments could be direct support. Massive government payments to farmers hide behind huge water consumption. Federal subsidies increased by a remarkable of 65% in 2020, totaling $37.2 billion. Corn prices were too low to cover the cost of growing in that year, with federal subsidies making up the difference. The subsidies put farmers on a treadmill, working harder to produce more while draining the resource that supports their livelihood. Government payments create a vicious circle of overproduction that intensifies water use. Subsidies encourage farmers to expand and buy expensive equipment to irrigate larger areas. Subsidizing corn production is supporting the U.S. economy. 16 separate sectors, from fast food companies to fertilizer manufacturers to grocery retailers, depend on U.S. corn as a key ingredient of their products or as a market for their inputs and services. In 2013, the top 45 companies in the corn value chain earned $1.7 trillion in revenue, more than the value of Australia's annual GDP. However, we might also find that even these hidden upstream companies are also looking for longer-term strategy. Companies like Cargill, ADM, and Bunge, which are the magnets of the corn manufacturing industry, is buying land all over the world. In March 2002, NASA and the German Aerospace Center took the Gravity Recovery and Climate Experiment mission, which can be also called GRACE. A twin satellites were launched to measure gravity anomalies, which indicates the change of water storage in aquifers. GRACE can clearly represent the water stress of groundwater depletion. The data generated by GRACE can provide guidance to food companies seeking water resources, as well as purchasing lands all over the world. ADM, for example, is related to collection, processing, and manufacturing of corns. With headquarters in Chicago, ADM now has processing and procurement branches all over the world. According to the data from Land Matrix, ADM is purchasing land in Africa and Asia. 14 international land trades are completed with the total deal size of over 4 million hectares. With the trend that big companies in the US are purchasing land worldwide, we have reasons to believe that North might not be the only destination for Corn Belt. It's more likely that the US Corn Belt will be international in 50 years.